Welcome everyone to today's lecture on potentiometry, a continuation of our introductory class. We're going to look into the reference electrode. As we discussed, potentiometry allows us to determine the concentration of solute in a solution by measuring the potential difference between two electrodes, the reference electrode and the indicator electrode. So in this lecture, I'm going to talk about the reference electrode. The reference electrode is mainly used for the determination of the analyte by maintaining the fixed potential. The ideal characteristics of the reference electrode is that it has to be stable, it should be reversible, it should be reproducible, it has to obey the Nast equation. As I said, it has to has a constant potential and also exhibit little change in temperature. The reference electrode is classified into two: the primary standard electrode and the secondary standard electrode. The primary standard electrode example of it is the standard hydrogen electrode, while the secondary standard electrode are the silver chloride electrode and the saturated calamol electrode. They are crucial for providing a stable point of comparison in a potentiometric measurement. Electrode. The standard hydrogen electrode, also known as the normal hydrogen electrode. As you can see, this is how it looks in the diagram. It is the primary reference electrode. It consists of platinum foil, which is coated with the platinum black and immersed in the hydrochloric solution. As you can see in the diagram, is immersed in the HCl solution, which contains hydrogen ions. Now, this hydrogen gas is passed over the platinum foil through the side tube. This is used for the entire pH range. It is mainly the standard hydrogen electrode. Its disadvantage is that its instability due to the presence of oxidizing and reducing agent and the purity of the hydrogen. The standard hydrogen electrode (SHE) is a reference electrode used in electrochemical measurement to provide a stable and reproducible reference potential. Its construction involves several key components and steps to ensure its accuracy and reliability. Here is a detailed description of its construction. The components are the platinum electrode. The platinum electrode is made up of platinum wire or foil, which is used as the base electrode. The platinum is chosen for its inertness and stability in electrochemical reaction. The surface of the platinum surface is often coated or treated to ensure it is clean and has high surface area. It may be covered with a thin layer of platinum black, that is a finely divided form of platinum, to ensure its catalytic activity. There is a gas supply, as you can see in the diagram, the gas inlet. The electrode is equipped with a gas inlet that allows hydrogen gas to flow over the platinum surface. The hydrogen gas used should be of high purity. It is often supplied from a gas cylinder and needs to be free from impurities that might affect the electrode's performance. Talking about the acid solution, the electrode is immersed in a standard solution of strong acid, typically 1 molar hydrochloric acid, to ensure a constant concentration of hydrogen ions. The concentration of the acid is crucial as it determines the pH of the solution and the activity of the hydrogen ions. The hydrogen gas needs to diffuse effectively over the platinum surface. The design often includes a mechanism to ensure uniform gas distribution and minimize bubbles or turbulence that could affect the measurement. The platinum electrode and the acid solution are housed in a suitable electrode body, often made from materials like glass or plastic that are resistant to chemical attack. The assembly must be sealed properly to prevent leakage of the acid or hydrogen gas and to ensure stable operation. The temperature, when we talk about standard condition, let's talk about the temperature. The standard condition for the SHE, the standard hydrogen electrode, are at 25 degrees Celsius, or we say 298 Kelvin. The electrode is calibrated and operated under these conditions to ensure consistency. The pressure also. The hydrogen gas is supplied at the pressure of 1 atmosphere to maintain standard condition. Talking about the reaction, the operation, the electrochemical reaction occurring at the standard hydrogen electrode, as you can see here, is when you have half molecule of, let's say 1 molecule of hydrogen gas, it will react and give 2 molecules of hydrogen ions. This reaction is at equilibrium, and the potential of the SHE is defined as 0.00 volt at standard condition. In use, the potential measurement in use, the SHE provides a reference potential, as I said, of 0.00 volt, against which the potential of other electrodes, that is the working electrodes, are measured. The potential of the SHE remains constant as it is defined as the standard reference electrode. Summarizing the overall construction and the components, the SHE is constructed using a platinum electrode, a high purity hydrogen gas supply, a standard acid solution. It operates under well-defined condition, 1 molar hydrogen ion, 1 molar HCl, 1 atmosphere atmospheric pressure of hydrogen gas, and at 25 degrees Celsius. And it provides a stable reference potential. As we say, it's a reference electrode anyway, so the reference potential has to be standard, has to be stable in one, it has to be in one position, and which is 0.00 volt for the electrochemical measurement. The construction ensures the electrode stability and reproducibility, making it a crucial tool for determining electrode potential and calibrating other electrodes. The saturated calomel electrode is a common reference electrode made from mercury and mercury-1 chloride, immersed in a saturated solution of potassium chloride. Its potential remains constant as well because, well, after all, it's a reference electrode. It has to be stable, making it ideal for use in potentiometric analysis. It consists of porous disc at the base of the electrode, which is clogged. Above it is the glass tube, The glass tube is filled with potassium chloride crystal, and above it is filled with the calomel paste, which is prepared by grinding of mercury chloride with pure mercury and minute milliliter, a minute milliliter of the saturated potassium chloride solution. Then pure mercury is placed in the electrode vessel. The advantage of this is easy to construct and it's highly stable. Following the steps, you just construct it easily without any problem. This is how the saturated calomel electrode looks like, as we can see. The silver chloride electrode is another reference electrode composed of silver wire coated with silver chloride and immersed in a solution saturated with potassium chloride. It's commonly used in potentiometric measurement due to its reliable potential, same as the saturated calomel electrode, where the silver wire is coated with the silver chloride solution. Here, the wire is dipped in the saturated potassium chloride solution. The cell consists of the following. As you can see, the silver chloride, and the potassium chloride. As you can see here, this is how the silver chloride electrode looks like. Indicator and reference electrode are both crucial components in electrochemical measurements, but they serve distinct roles in the process. Here is a detailed comparison. Number one, talking about the function. The indicator electrode measures the potential of the analyte in the solution relative to its reference electrode. The potential measured is indicative of the concentration of the specific ions or pH of the solution. Example, a pH glass electrode for measuring pH, or an ion selective electrode ISE designed for specific ions like sodium, potassium, or chloride. While the reference electrode provides a stable and constant reference potential against which the potential of the indicator electrode is measured, it contains a fixed potential that is unaffected by the composition of the solution being tested. Example is a saturated calomel electrode or a silver chloride electrode. The construction. The indicator electrode typically consists of sensing element that interacts directly with the analyte. For instance, a glass electrode has a glass membrane that is sensitive to hydrogen ions. Remember I said in the class. While an ion selective electrode contains a membrane selective to a particular ion. The materials used is specific to the type of measurement. For pH measurement is usually made of special glass. For ion selective electrode, it may be a polymer or crystalline materials, selective for the ion of interest. While the construction of the reference electrode, it contains a stable reference system, usually with a known and constant composition. For example, a calomel electrode has mercury and mercurious chloride. Silver chloride electrode has a silver wire coated with silver chloride. And the materials used are chosen for their ability to maintain a stable potential. This often includes elements like silver, mercury, and calomel, that is mercurious chloride. The calomel is called mercurious chloride. Its role also, This indicator roles in measurement. The indicator electrode detects changes in the analyzed solution or pH by responding to the electrochemical potential at the surface of the electrode. The potential change is used to determine the concentration of the analyte. The response of the indicator electrode is specific to the ions or pH of the solution it is measuring, while the reference electrode provides a constant reference potential to which the potential of the indicator electrode is compared. This stable reference allows for accurate measurement of the potential difference. The potential of the reference electrode remains stable and does not change with the solution composition. Now, when we talk about stability of the indicator electrode, its performance can be affected by factors such as contamination, aging, changes in solution, regular calibration, and maintenance are required. While the reference electrode is designed to provide a stable reference potential over time and is less affected by sample solution. The indicator electrode needs to be clean, calibrated, and sometimes replaced depending on the usage or how it's being used. While the reference electrode requires less frequent maintenance but needs to be kept in proper storage conditions to maintain stability. The indicator electrode is used as the working electrode in an electrochemical cell, where it interacts with the analytes to generate a measurable potential. While the reference electrode is used in conjunction with the indicator electrode to complete the electrochemical cell, it provides a constant reference potential to measure the potential difference accurately. I hope you understand the difference between reference electrode and indicator electrode. But in summary, if I'm to summarize everything, the indicator electrode measures potential related to the analyte, be it pH or specific ions. pH meaning the hydrogen ions, right? And it provides data on the concentration or activity of the species of interest, meaning your sample. While the reference potential, I've always said a reference is just there for reference, it is stable and has known reference potential against which the potential of the indicator electrode is measured, ensuring accurate and consistent measurement. Thank you. I hope you understand the overall use of a reference electrode. Thank you.